lesson 4 of our trig unit. So we are going to be talking about the unit circle today. Okay? So to start, let's look at the do now. It says, which diagram represents an angle, alpha, measuring 3 pi over 20 radians, drawn in standard position, and its reference angle theta. Okay? Now, if we look, all of the angles are the same. They're all in the second quadrant. So we really have to see which is alpha, which is the angle in standard position, and which is theta, which is our reference angle. So let's look here. If we look at the first one, okay, it tells us that alpha is what I drew in red, and that theta is what I drew in blue. Now, alpha, which is our regular angle, and theta, which is our reference angle, are not the same unless they're in quadrant 1. So 1 is out. So let's look at answer choice 2. It says that this here is alpha. Now that does not work because in order to have an angle in standard position, you start at your x-axis and you go counterclockwise. So 2 is out. Let's look at 3. So for answer choice 3, alpha is right over there, which is the correct alpha for a standard position. However, the reference angle is right over there. The reference angle is made from the x-axis, not the y-axis. So 3 is out. So by process of elimination, 4 is our answer, but let's talk about why. So for 4, it has that angle there to be alpha, which is correct because it starts from the x-axis and goes counterclockwise to our angle. And remember, the reference angle is the smallest angle made from the x-axis. So if we look here, theta is definitely smaller than alpha, and it is made with the x-axis, not the y-axis, like in answer choice 3. Okay, so we are going to talk about these important trig values. Now, we are going to be using these trig values a lot. So this is a table that you may have to memorize, so I suggest you writing it down. Now, there are ways to remember this, okay? So I'm going to show you some tips and tricks. To start, these are all degrees. So this is 0 degrees, 30 degrees, 45, 60, 90, 180, 270, and 360, okay? Now, I am going to kind of split up the 30, 45, and 60. This has a different pattern that we're going to look at right after. So, we're going to start at sine of 0 degrees. Sine of 0 is 0. Cosine of 0 is 1. And tangent of 0 is 0. So notice it goes 0, 1, 0. That's going to be a recurring pattern. So now we're going to look at sine only. We're going to kind of skip this middle section for right now, and we're going to go to those angles. Now, 0, 90, 180, 270, 360. We've seen that before because those are the degrees of our quadrants. 0, 90, 180, 270, and 360. Okay, so those are important angles that we keep seeing. So now look at the pattern. It's going to go in a 0, 1 pattern. So this is 0, next comes 1, next comes 0, next comes -1, next comes 0. Same pattern applies for cosine, except now we start at 1. So it's 1, 0, -1, 0, 1. Tangent's pattern is a little bit different. It goes tangent, which is 0. Then we have undefined. So undefined, 0. Undefined, 0. So that is the pattern for those specific angles. Now, 30, 45, and 60 have a different type of pattern. Everything is going to be over 2. Okay? for the sine and cosine. Now, we're going to use a 1, 2, 3, 3, 2, 1 pattern. So for sine of 30, it is radical 1 over 2. Keep in mind though, radical 1 is just 1. For sine of 45, it's radical 2 over 2. For sine of 60, it's radical 3 over 2. So this is where that 1, 2, 3 pattern comes in. Now cosine has the same pattern, but in the opposite way. So instead of 1, 2, 3, it goes 3, 2, 1. So radical 3, radical 2, and radical 1, which is just 1. Tangent is where we have a little bit more work to find it. So the tangent of an angle, so the tangent of theta, this is equal to sine of theta over cosine of theta, okay? So to find the tangent of 30, we have to do sine of 30 divided by cosine of 30. So we put in what we have. So sine of 30 was 1/2. So this is equal to 1/2. Instead of that bar, I'm going to use the division symbol. Okay? And then cosine of 30 was radical 3 over 2. The reason I did this is now we can use keep, change, flip in order to divide these. So you keep the 1/2, change the division to multiplication, and flip the last fraction. So if you simplify, these 2's will cancel, and you're left with 1 over radical 3. So the tangent of 30 is 1 over radical 3. And now we follow this process along. So to find the tangent of 45, we have to do the sine of 45 divided by the cosine of 45, which is radical 2 over 2 divided by radical 2 over 2. We use keep, change, flip. Keep this, change to multiplication, flip the last one. Now everything actually crosses out here, which tells us this is equal to 1. So tangent of 45 is equal to 1. We have one last one to do, which is the tangent of 60. So the tangent of 60 is the sine of 60 over the cosine of 60. The sine of 60 was radical 3 over 2. The cosine of 60 was 1 over 2. Keep, change, flip. We get radical 3 over 2 times 2 over 1. 2's cancel. And we get radical 3. So the tangent of 60 becomes radical 3. So the reason we're going over these is because you are going to need to memorize these different values of sine, cosine, and tangent. But remember the tricks. So for sine and cosine, they alternate 0, 1, 0, negative 1. You just need to know that this first column starts 0, 1, 0. And then for here, remember the 1, 2, 3 trick, and then 3, 2, 1. And then for tangent, you have a little bit more work to do, just using that ratio there. Okay, so the unit circle. The unit circle is a circle on a coordinate plane that has a radius of 1. So remember, the radius goes from the center to the circumference of the circle. So it's half of the diameter. So the radius for all unit circles is going to be 1. That is super, super, super important. Here's just another example. The radius does not only have to be on the x or y axis, it could be anywhere in the circle. As long as it goes from the center to some point on that circle, that radius will be 1. So let's recall in which quadrants the trig ratios are positive. So this is what we did in the previous lesson. So the way that we remember this is using all students talk constantly. So this A tells us that all trig ratios are positive. This S tells us that sine and its reciprocal, which is cosecant, are positive. This T tells us that tangent and its reciprocal, which is cotangent, are positive. And lastly, this C tells us that cosine and its reciprocal, which is secant, are positive. Okay? Now, to find the exact trig value, we're doing the same thing as we did yesterday. So drawing an angle in standard position. The only difference here is that our point will be on a unit circle. Since it's on a unit circle, this is super important. The hypotenuse of our triangle will always be 1. So make sure you look out to see if you are on a unit circle. Alright, so let's look at this one. It says, the terminal side of an angle theta passes through the point -6/7 and radical 13/7 on a unit circle. Extremely, extremely important. And it tells us to find all 6 trig ratios. So we were given a point. Let's see what this looks like. Now, it might be a little bit harder to graph this point because it's a fraction and some square root of 13. Where is that? But just look at the signs. So this x is negative, so it'll be somewhere here. The y coordinate is positive, so it means the point is going to be somewhere in the second quadrant. Okay, we don't know exactly where because we don't know exactly what those numbers are, but that's okay. So once we have our point, which was -6/7 and radical 13/7, we make our triangle. So to make our triangle, we connect the point to the origin, which is the middle, and then we drop a line down to the x-axis, okay? And then we complete our triangle. Our right angle is going to be in that corner over there. So this distance here is our x-coordinate. Our x-coordinate is -6/7, but this distance will just be 6/7 because we can't have a negative distance in math. This distance here is our y-coordinate. Our y-coordinate is radical 13/7. And now our hypotenuse. Since we are on a unit circle, this tells us that our hypotenuse is 1. So our hypotenuse here is 1. We don't have to use the Pythagorean theorem here. If you did use it, you would get 1. Okay, so now let's find all the trig ratios. So we have sine. Let's start with finding sine of theta. We have to know exactly where theta is, and theta, to mark it, we always look at the x-axis, create your little curve, and that is where theta is. It's always the part that's next to the x-axis. So sine of theta, to find sine of theta, you use SOHCAHTOA. So sine is so. So it's the opposite over the hypotenuse. Now the opposite sine of theta is radical 13/7. And this is going to be over the hypotenuse, which is 1. Now this can kind of look a little confusing because you have so many fractions going on. So if you would prefer to write it like this, divided by 1, you can. Now, since it's getting divided by 1, nothing is going to change. So the sine of theta is radical 13 over 7. What you do have to keep in mind of, though, is the sign of this. So to figure out if this is positive or negative, you use all. Students talk constantly. So we are in the second quadrant where sine is positive, so this is positive. Okay? Now the next thing we are going to find is cosine of theta. So to find cosine of theta, you use c. So adjacent over hypotenuse. The adjacent side of theta is 6 over 7, and it's going to be over the hypotenuse, which is 1. But again, if you don't like writing a fraction divided by another fraction, you can always do it like this. Okay? 6 over 7 divided by 1 would just give us the 6 over 7. This is in the second quadrant, so only sine is positive, which tells us that cosine has to be negative. Lastly, let's find tangent of theta. So tangent of theta, you use TOA. So opposite over adjacent. The opposite side is radical 13 over 7. So we don't have a fraction divided by a fraction. I'm going to write it with the division symbol. And the adjacent side is 6 over 7. So when we are dividing fractions, we use keep, change, flip. So keep radical 13 over 7, change this to multiplication, and flip the last fraction. The 7s will cross out because one's in the numerator, one's in the denominator, and you get radical 13 over 6. Since we're in the second quadrant and only sine is positive, this is a negative 13 over 6. So we just found 3 of the trig ratios, so we have to find the other 3, so the reciprocal trig ratios. The reciprocal of sine is cosecant of theta, and to find the cosecant, just find the reciprocal of sine. So just flip this over, and you get 7 over radical 13. You can put this in, you can rationalize this, so multiply the top and bottom by radical 13. If you want to review how to do that, go back to lesson 1 in the do now. So cosine of theta, the reciprocal of cosine, is secant of theta. Again, just flip it and you get negative 7 over 6. And lastly, the reciprocal of tangent is cotangent. So to find the reciprocal, just flip it. So negative 6 over radical 13. And that's how you find all 6 trig ratios on a unit circle. It's the same thing we did yesterday. The only difference is the hypotenuse is 1. Okay, another type of question. It says the point P, which is x comma negative radical 13 over 7, lies on the unit circle. What is the value of x in simplest form? Okay, so they give us half of a point. Let's figure out where this point will be. Alright, so x, they don't give it to us, so we can assume that it's going to be positive. And then we have negative radical 13 over 7. So the y-coordinate is negative. That means it's going to be somewhere over here. Okay, we don't know exactly where because we don't know the x, but that is okay. Next thing, let's draw our triangle. So connect from the origin, drop it down to the x-axis, and finish up your triangle. So this is x and negative radical 13 over 7. Let's label this as much as we can. This x distance, we don't know it. That's what we're trying to find. So we can label it x. Our y distance, they give us our y coordinate. So this is radical 13 over 7. Keep in mind, you cannot make this negative because it is a distance of a triangle. And lastly, our hypotenuse. It tells us that it lies on the unit circle, so our hypotenuse is automatically 1. Okay? Now, all we have to do to find x is use the Pythagorean theorem. We have a right triangle here. So, let's use the Pythagorean theorem. A squared plus b squared equals c squared. Remember, c is always your hypotenuse, and a and b are the two legs of your triangle. So a is x. We don't know that. That's what we're going to try to find. Okay? Let's make b radical 13 over 7. And c is 1. Because that is our hypotenuse. Okay, so this stays x squared plus. Now I want to talk about this for a little bit. We can apply this exponent to the numerator and to the denominator. So this can actually become radical 13 squared over 7 squared. Okay? And now 1 squared, 1 times 1 is 1. Now to simplify more, we get x squared plus the square root of 13 squared. The radical and the exponent, they cancel out. So we get 13 over 7 squared is 49. And that's equal to 1. Now, to solve, we're subtracting 13 over 49 on both sides. When we do that, we get x squared equals, and let's figure out what that's equal to once the calculator loads. So we have 1 minus 1 minus alpha, y equals, enter, and we're putting in 13 over 49. Make sure you use the alpha y equals button. It's very, very helpful. And we get 36 over 49. So x squared is equal to 36 over 49. Now we have to take the square root of both sides in order to get x by itself. So those cancel out. We're left with x equals. Now, again, this square root, we can apply that to the numerator and to the denominator separately. So the square root of 36, this gives us 6. The square root of 49, this gives us 7. Okay? So now we have x is equal to 6 over 7. So that there is our final answer. And that is all. Alright, to get credit for today's lesson, please complete this problem on a separate piece of paper and then upload a picture of your work and your answer to the assignment posted on Google Classroom.